This video is on the launch questions 1 and 2. In the diagram below, triangle A, B, and C is similar to triangle R, S, and T. So these are similar triangles. These are similar triangles, which to me, by the way, the squiggly line means similar. Similar. It means that all the letters A, B, and C, R, S, T are also in corresponding order as well. So the question is asking which statement is not true, and it says is angle R equal to angle A? Well, that is true. That is one of the properties of similar triangles. Is A and B corresponding with R and S? Is B and C corresponding with S and T? And that is also true. Is A and B corresponding to B and C? Or in this case, look at this one. Is A and B corresponding to S and T? No, they're not corresponding sides. Is BC corresponding to RS? No, they are also not corresponding sides. So that one's not true. The last one is a little weird looking. It looks complicated at first, but what it means is are the sides, this top line here means is the perimeter of this triangle and the perimeter of the similar triangle also in proportion. And what I want you to consider is that perimeters of similar triangles are also in proportion. So that means the sides are in proportion, the perimeters are in proportion. The areas are not in proportion. They are scaled by a squared factor. We've talked about that previously, but perimeters of similar triangles they also have the same scale factor. So that is true. That's what this means. Okay, number 2, scaling triangle A, B, and C is similar to triangle D and F. A scaling triangle is a triangle that has all different length sides and angles. Angle measures length sides. So we have equilateral triangles that are equal on all sides. We have obtuse. Nope. We have isosceles triangles, which have 2 legs that are equal, and we have scaling triangles, which means all different length sides happen with these 3 sides of a triangle. Now, they're just saying that this triangle is similar to triangle D and F, which statement is false. This is tricky because there's no picture given, and although you could draw a picture, this question is asking you, the first letter in here corresponds with the first letter in D, E, F. B is the second letter in here. It corresponds with the second letter E. C is the third letter in this name of the triangle, and it corresponds with F. So given this part here, you could actually figure out the rest. Now it says A, B. For example, there's like this colon right here. That is a ratio. That means you can rewrite it as this. You can rewrite it as AB to BC. You can rewrite this whole thing as this. That's okay. So let's give that a shot here. Let me just move this really fast. Oh, isn't that cool? I can move that. All right, so for A, it says is AB to BC. Is that true? DE to EF. And if you look here, that it's corresponding. AB corresponds to DE. That's true. BC corresponds to EF. That's also true. So that is true. There's a lot of these false, not true questions today, so just hang in there. Is AC the first and third letter proportional? So this number 2, is AC proportional to DF? And is that equal to BC being proportional to EF? So again, you can match up here. For example, this is the first and third letter, AC. Does that match with this first and third letter? Yes. And BC are the second 2 letters, and E and F are the second 2 letters. So yes, that is also true. This says, is angle ACB congruent to angle DFE? So let's just look at the center letter because that's actually the angle. And is C corresponding to angle F? Is angle C corresponding to angle S? Yes, it's also true. So let's hope that this last one is not true. So is angle B, we're going to look at the center letter because the angles, you have to name the 2 adjacent vertex and then the vertex that we're talking about with the angles in the middle. So you have A, B, and C. Is that equal to E, D, and F? And B and D are not corresponding, so this is not true. So your answers are 3 and 4 for the launch.